Sound check 1. Okay, good afternoon. Looks like everything's working, so we're going to go ahead and get started. Just want to remind my students that you can post your name or alias in the chat bar, and as well as the days and times of your class. I'm going to type this in here, so you can post your name or alias, and then MAT1033, and then the days and times of your class to get bonus points. Also, as I'm going along, you can feel free to ask questions in the chat bar or ask me to repeat things. You're not bothering me at all. There is a little bit of a delay between when I speak, when you hear me, and then again between when you type and I see your message. So just be patient and I will get to your question. Okay, so today we're going to talk about slopes some more, and we're going to talk about particularly slopes of lines that are parallel and slopes of lines that are perpendicular. But before we do, I just want to remind you that we've been talking in class about a couple of formulas that involve slope. We've talked about the equation of a line can be, if we solve for y, get y by itself, the equation of the line can always be written in the form y equals mx plus b, where m is the slope of the line. And if you have, in a different context, if you have 2 points, x1, y1, and x2, y2, you can always find the slope of the line that goes through those 2 points using this formula for slope, m equals y2 minus y1 over x2 minus x1. And as you're working through your ALEKS work, one of the questions you might come across that people find a little bit challenging is this one. It talks about finding the missing coordinate that yields a given slope. And what it says is there are 2 points, the point 4r and the point 8, -2 that lie on a line. So you see how we're missing one of the coordinates. And they tell us the slope of that line is -5/4. So if we wanted to find the missing coordinate, how could we go about doing that? Well, do you think we would use the y equals mx plus b form? Or do you think we would use the formula for the slope between 2 points? Well, hopefully you said the formula for the slope between 2 points, because we're talking about 2 points in a slope. So that's what we're going to do. I'm going to copy that formula down over here, back where my problem was. So we have m equals y2 minus y1 over x2 minus x1. And we have a whole bunch of this information. Let's think of 4r as being our pair of coordinates x1, y1, and 8, -2 as being our pair of coordinates x2, y2. You can switch that around, by the way. There's no particular reason to choose 4r to be the x1, y1. It's just a random choice. But this is going to be our m for sure, -5/4. And so we're going to plug in everything we have to this formula, this relationship. So we're going to say, instead of m, I'm going to put -5/4 equals instead of y2 minus y1, I'm going to have negative 2 minus r. And instead of x2 minus x1, that would give me 8 minus 4. And so what we see is we now have an equation with only one unknown, and we can try and solve for that value r. So I'm going to simplify a little bit here. 8 minus 4 is 4. So we have negative 5/4 equals negative 2 minus r over 4. Now this particular type of, hello Christina, thank you for posting. This particular type of equation is called a proportion because you have one fraction on the left equal to one fraction on the right. And one method that people use to solve a proportion is called cross multiplying. I kind of don't like that expression because people then think that it has something to do with multiplying fractions, which it doesn't. Cross multiplying is a shortcut for solving a proportion. But anyway, you are going to multiply negative 5 times 4, so negative 5 times 4. And then on the other side, you're going to have 4 times negative 2 minus r. All right, this is a linear equation because r is not squared or cubed, or there's no square root on it, anything like that. So we're going to multiply through the parentheses and isolate the variable. So negative 5 times 4 is going to be negative 20. Distributing the 4 to the negative 2 and the negative r, we're going to get negative 8 minus 4r. We always want to get the terms that have variables on one side and the constant terms to the other. In this case, there's already a constant term by itself on the left, so I'm also going to move that 8 over there by adding the opposite. We can do whatever we want to both sides of the equation, or rather, whatever we want to the equation as long as we do it to both sides, I should say. And there's Devonique. Thank you for posting. All right, so we're going to have negative 12 equals, these give us 0, which we don't need to write, negative 4r. Now, how do we get the r completely by itself? What's the last step here? So sometimes a common error is to think that you need to add 4 to both sides because people see the negative. But remember, that's not the determining factor. What you have to focus on is the operation. This negative 4 is being multiplied by r. So we need to reverse that operation. So we're going to divide both sides by negative 4 because negative 4 goes into negative 4 one time. 1 times r is just r, so that effectively gets r by itself. Now negative 12 divided by negative 4 is positive 3, so r must be 3. So our original pair of coordinates would have been 4, 3. They had to have been in order to get a slope of negative 5/4. And so if you plugged into the slope formula the 4, 3 and the 8, negative 2, you should simplify it and get negative 5/4. But the answer they were looking for in ALEKS would have been 3 for this problem. So when you come across that problem in ALEKS, hello Sarah, welcome, you're going to work it in this way. Any questions or comments? Remember, you can type any questions, comments into the chat bar. You can also ask me to repeat something. If you're watching the recorded version of this, not during the live chat, you can of course rewind the video and watch it again if you need something repeated. Okay, let's go on now to another problem. Finding the slope and y-intercept of a line given its equation in the form ax plus by equals c. Does anyone remember what this form is called? Ax plus by equals c. Not sure if we discussed it in class last time. Type it into the chat bar if you know it. I'm giving you a minute because there's a little bit of a delay between when I talk and when you hear me, and when you type and when I see it. So there's a little bit of a lag, kind of like when you're watching the news and they're interviewing someone who's like across the world. No, nobody remembers? Is it slope-intercept form, or is it general form? Or standard form? There you go. Christina got it, standard form. Okay, so standard form unfortunately is not usually very useful to us, so we really would prefer a different form. What form gives us the slope and the y-intercept? Well, you can tell by the words. The form that gives us the slope and y-intercept is the slope-intercept form. That's the one we mentioned at the beginning of the lesson. Slope-intercept form is y equals mx plus b. That is not what we were given, but if we had it, we could easily identify the slope m and the y-intercept b. So the method that we use is to get y by itself in our equation, put it into the slope-intercept form, and then we can identify the slope and the y-intercept. So I'm going to rewrite my equation here, negative 12x plus 4y equals negative 4. By the way, the important thing about identifying standard form is just that you see that the x term and the y term are on the left, and then the constant term, the number, is on the right. Okay, so that's what constitutes standard form. It's nothing amazing. It's just, you know, we've moved the x and y's to the left. So now we're going to reverse that. We would really like to get y by itself, so I'm going to move the 12x term to the right. This gives us 4y equals 12x minus 4. And then, by the way, you could write negative 4 plus 12x, but remember, we're trying to match it up with y equals mx plus b, right? So we generally put the x term first. All right, now to get y completely by itself, we need to do what? We need to reverse that operation of multiplication. So we need to divide both sides by 4. And when you do that, you're dividing the whole thing by 4. So you end up having to divide each part. It's kind of like how when we distribute each part of the sum or difference when we're multiplying. You do the same thing when you divide. Okay, so we're going to have 3x minus 4 divided by 4 is 1. All right, so now we have the slope-intercept form that we talked about. And we just need to identify our m and our b. M is the number in front of x, which is 3. And notice that if we had made the mistake of thinking we always take the number in front of the x no matter what form it's in, we would have said negative 12, which would have been wrong. You have to rearrange the equation to slope-intercept form to know what the slope is. And then b is that negative 1. So this tells us that the slope we're looking for is 3. And that the y-intercept we're looking for is negative 1, or I prefer to write it as 0, negative 1, because really it's a pair of coordinates, but I believe in Alex they let you get away with just typing in the negative 1. So, okay, don't be shy about typing in any questions you might have good as we go. All right, so that was sort of some stuff we've looked at before, maybe a slightly different angle, but basically we've seen that stuff before. Now we're going to look at parallel and perpendicular. So when two lines are parallel, we know that they have the same slope. And that looks like this right here, right? They're running alongside each other, the same slope. They're going in the same direction. So they never bump into each other, right? They just run alongside. When two lines are perpendicular, what that means is that they're meeting at a right angle. And that means that their slopes are what I refer to as opposite reciprocals. So examples of opposite reciprocals would be like the number 1/2. Its reciprocal is 2, but the opposite of its reciprocal would be -2. Reciprocal is just where you flip the number over. So if you multiply, by the way, opposite reciprocals together, you always get -1. So one way to test if two lines are perpendicular is to multiply their slopes together and see if you get a -1. You also can just look, kind of eyeball the slopes and see if they're opposite reciprocals. So for example, if I gave you the line y equals 2/3 x minus 1 and the line y equals 3/2 x minus 5, you would look at these and you'd say, okay, they're not parallel because they don't have the same slope. Are they perpendicular? Well, they're reciprocals, their slopes are reciprocals of each other, but they're not opposites. So this is actually neither parallel nor perpendicular because it doesn't meet the definition. Or to check for perpendicular, you could actually multiply the slopes. You'd get 6/6, which is 1, which is not equal to -1, so they're not perpendicular. Okay, so this is what we're going to be working with in this chat for the next couple of problems, determining when pairs of lines are parallel or perpendicular or neither. Okay, so for item number 3, and remember this is all in your OneNote folder, so you can actually pull up this folder at home through the link in D2L if you want to. We're going to be finding slopes of lines that are parallel and perpendicular to the given line, and they're giving us the line in the form ax plus by equals c, which we said was standard form. Christina has a question. So for both parallel and perpendicular, it's always supposed to be -1. Oh, no. The reason why this is not parallel means you have the same slope. So the reason this wasn't parallel is because 2/3 does not equal 3/2. So we knew it's not parallel. It's not perpendicular because the product of the slopes are not -1. So therefore it's neither. Okay, I hope that clarifies it. So always, if you're asked if it's parallel, perpendicular, or neither, first check to see if it's parallel, if the slopes are the same. In this case, they're not. Then check to see if they're perpendicular, if they have opposite reciprocal slopes that multiply to give you -1. In this case, they're not. So the answer is neither. Okay, so back to this problem. We're going to answer 2 questions about this line. Part A, what is the slope of a line that would be perpendicular to this line? And B, what is the slope of a line parallel to this line? So in order to answer those questions, though, we need to know the slope of the original line, because the parallel slope would be the same or equal slope to the original line, and the perpendicular line would have a slope that is an opposite reciprocal that multiplies to give you -1, in other words. Okay, so let's go ahead and find the slope of this line. Now, is the standard form a good form for finding slope? Can I just read the slope off of this equation? No, I can't read the slope off of the equation unless we get it into slope-intercept form, y equals mx plus b. So that's the technique that I recommend that you use when you're identifying the slope given the equation of a line. Make sure you have it in slope-intercept form. So I'm going to write down -3x minus 2y equals 4. I'm going to add 3x, the x term, over to the other side. That's pretty much always the first step. So that's going to give you -2y equals 3x plus 4. And then the next step is pretty much always the same also. Any coefficient you have in front of the y, coefficient just means number being multiplied by the y, we need to divide both sides by that value to get y by itself. So I'm going to divide both sides by -2. So that would mean that y is equal to, now avoid the common error of just dividing one part by the -2. You have to divide both. So that means that we're going to have -3/2 x minus 4 divided by 2 is 2. So our slope of our original line is -3/2. Now I'm actually going to answer these questions in reverse order because part B is easier than part A. So you tell me, if the original line had a slope of -3/2, what would be the slope of a line parallel to that? Can you type that slope into the chat bar for me? We are looking for the slope that would be parallel to a line with a slope of -3/2. Very good, -3/2. That was Aisha. Good job. Okay, parallel just means same slope. Same slope as the original line, so that's going to be -3/2. Okay, how about part A, when we're looking for a slope of a perpendicular line? Okay, we want something with a slope that's perpendicular to -3/2 now. So remember we said opposite reciprocal slope. So you need the reciprocal, which means flipping it over, and you need a positive instead of a negative. So very good, Aisha, that would be +2/3. She flipped it and she changed the sign to a positive. Okay, so when you're asked for parallel slope, that's the easiest question on the test because it's just going to be the same slope you already had. The work is actually usually in finding the slope of the original line like we had to do here. We had a little rearranging to do to get it into a form where we could see the slope. But after that, any line parallel to that line is going to have that same slope. Perpendicular is a little harder. You just have to flip it over and change the sign. Okay. There's a question in Alex related to this that I would like to go over. It says identifying parallel and perpendicular lines from equations. The equations of 3 lines are given. We have line 1, line 2, and line 3. And then what they're going to ask us is to pair them up and decide if each pair is parallel, perpendicular, or neither. So we're going to compare lines 1 and 2, lines 1 and 3, and lines 2 and 3. Okay, but before we can do all of that, we need to know the slopes of each of the lines. So let's look at line 1. It's not quite in y = mx + b form. Y is not completely by itself, and we really want y = mx + b form so that we can find m, the slope. So in this case, I would need to divide both sides of the equation by 2, the coefficient of y, and that is going to give us the equation y = -5/2 x plus 5/2. Remember to divide both parts by the 2. Okay, so slope 1, I'm just putting this little subscript 1 to indicate it came from line 1. Slope 1 is the coefficient of x, -5/2. Okay, now let's find slope 2. So for slope 2, we have a little bit more work to do. I'm going to come off to the side over here. We have 4x minus 10y = 6. We need to get y by itself again. So I'm going to subtract 4x from both sides. And we're going to do -10y = -4x plus 6. All right, then we divide both sides by the coefficient of y. So divide both sides by -10. And we get y equals, now -4 divided by -10 is a +4/10, which reduces to 2/5 x, and then minus 6/10 or minus 3/5 if you reduce. You should always reduce. So if you know you've reduced everything to lowest terms, you can compare them safely. So in this case, this one turned out to be y equals 2/5 x minus 3/5. So we're looking at the coefficient of x, and so slope of line 2 is 2/5. And then finally line 3, actually we're lucky because line 3 already has it in y equals mx plus b form. So we can see that slope 3 equals -5/2 without having to do any work. Let me write it again out here where they're all lined up nicely. So we're comparing pairs of slopes here. Remember this, if they have the same slope, they're parallel. If they have opposite reciprocal slopes, they're perpendicular, and anything else is neither. All right, so let's look at line 1 and line 2. You tell me, line 1 and line 2, look at their slopes. Tell me, is it parallel, perpendicular, or neither? Type it into the chat bar. Very good, Christina. They're perpendicular. That's right. They're definitely not parallel. We're looking at -5/2 and positive 2/5. Those are different numbers. So they definitely cannot be parallel because they don't have the same slope. To check if they're perpendicular, you would multiply -5/2 times positive 2/5. You get -10/10, which is -1. So they are perpendicular. Okay, how about line 1 and line 3? Are they parallel, perpendicular, or neither? So line 1 has a slope, oh, you know what? You're right, Christina. That would be neither, except for I copied the slope down wrong. All right, sorry guys. That should have, I'm going blind in my old age. That should have been a -5/2 there. So are they parallel, perpendicular, or neither if they both have a slope of -5/2? Very good. They're parallel. Okay. And then how about line 2 and line 3? Parallel, perpendicular, or neither? That's right, they're perpendicular. Line 2 has a slope of positive 2/5. Line 3 a slope of -5/2. We already multiplied those together before, and we saw they multiply to give you -1. They're opposite reciprocals, so we get perpendicular. Now be careful on Alex. You know how you have to work the same topic several times, and when they regenerate the question, sometimes, you know, they'll turn out to be perpendicular, parallel, and perpendicular. Sometimes it'll turn out to be neither. Okay, so for example, this is a different example, so don't get it confused. I'm going to scroll up. All right, so what if line 1 had a slope of m1 equals 2/3, and line 2 had a slope m2 equal to negative 2/3, and line 3, m3, the slope was negative 3/2. Okay, so comparing lines 1 and 2, are they parallel, perpendicular, or neither? Okay, so first of all, check if they're parallel. Are they the same slope? No, they're not the same slope, so they're definitely not parallel. Are they perpendicular? Well, 2/3 times negative 2/3 is negative 4/9. It's definitely not negative 1. So the answer is neither. They are not perpendicular. They are not opposite reciprocals. They're opposites, but not reciprocals because they're not flipped over. Okay, so you might get a question like that. Lines 1 and 3 now are actually not the same slope, so they're not parallel, but they are opposite reciprocals. One's positive, one's negative, and they are flipped over versions of each other, so they're perpendicular. And then lines 2 and 3. What can you tell me about lines 2 and 3? 2 and 3 have slope negative 2/3 and negative 3/2. So are they parallel, perpendicular, or neither? Okay, very good. Neither. So they are reciprocals, but they're not opposites. So, and they're definitely not equal. So they are neither parallel nor perpendicular. They're neither. Okay, so that's all for the live chat for today. Are there any questions from anybody? And while I'm waiting to see if you type anything into the chat bar, I just want to ask you, if this chat was helpful to you, to please give it a thumbs up, because that helps other students to find the video. Are there any follow-up questions before I log off? Okay, so anybody who's watching the recorded version of this can still get the bonus points by typing a comment into the chat bar. The instructions are in D2L. The link to the recorded version is in D2L in the OneNotes file. And you can also find all the notes that we wrote down in your OneNote file as well. So all of this is saved for you. Okay. All right, you guys have a great long weekend, and I'll see you in class next week. But in the meantime, if you have any questions, don't be shy about sending them to me. That's right, Christina. When slopes are both negative or both positive, in either case, they can't be perpendicular. They have to be opposites. So one positive, one negative. Doesn't matter which one's positive, which one's negative, but they have to be opposites of each other. Okay. All right. So email me if you have any questions. Remember, D2L is not the fastest way. I answer D2L emails on Fridays, but I don't guarantee in between. So use qhearn@broward.edu or Skype me. Okay. Goodbye, everybody. Have a good weekend.